Today we will see the example 2.8 of Griffith fourth edition Introduction to Electrodynamics. The example 2.8 is find the potential of a uniformly charged spherical shell of radius r as given in the figure. This is x direction, y direction and z direction. We have to find the field at the point P, which is at a distance z from the origin. So, by definition, the potential V of z is equal to 1 over 4 pi epsilon naught integral sigma Ta over script r. We have taken a small area segment, this. And distance from this area segment to the point under consideration is script r. So sigma Ta divided by script r. Script r can be calculated using cosine law. What is cosine law? This is cosine law says that the script r is equal to the angle enclosed by this script r is this theta. Here it is given as theta prime. We will take as theta for convenient. So the angle enclosed by the theta is the arms are z and r. So according to cosine law, the script r is equal to this z squared plus r squared minus 2z r cos theta. That is square root of z squared plus r squared minus 2z r cos theta. That is the angle enclosed by the script r. And the area segment is equal to r squared. This r is fixed, so you are not going to integrate with respect to r. So r squared sine theta t theta t pi. So you can rewrite this expression. V of z is equal to sigma divided by 4 pi epsilon naught. I have taken sigma out as it is a constant. And I replaced r by z because we are considering along z direction. So here Ta is equal to r squared sine theta t theta t pi divided by square root of divided by script r, which is nothing but square root of z squared plus r squared minus 2z r cos theta. Now we will integrate this. So now we got this integral. Now what I am going to do is I am going to separate this into two integral. One integral is with respect to pi, other one is with respect to theta. First you take the theta integral. This will become r squared sine theta t theta divided by this square root term, and I am separating this t pi outside this one. So this limit of this integral is 0 to 2 pi because pi varies from 0 to 2 pi. So now this integral value is equal to 2 pi. This is 2 pi. So this 2 pi will get cancelled with this 4 pi will become 2. So this will get cancelled. So now you will get r squared is a constant I am taking out. So sigma r squared divided by 2 epsilon naught integral 0 to pi sine theta t theta divided by this square root term. Now what I am going to do is I am going to take cos theta as u. So cos u is equal to cos theta, then du is equal to minus sine theta t theta. Or you can say this sine theta t theta is equal to minus du. So I am replacing this integral as minus du divided by this square root term. Here I am replacing cos theta by u. Now we have to change the limit also. When cos theta equal to 0, cos 0 is 1. So I have taken a lower limit as 1. What will happen when cos theta equal to pi? when theta equal to pi, this will become minus 1. So upper limit is minus 1. Here we have minus tu. So you can change the limit 1 to minus 1. You change minus 1 to 1. Then this minus will go away. So you will get this integral. Now we will solve this integral. Now we have to carry out this integral. This can be rewritten as this square root term z squared plus r squared minus 2z r u power minus half. So if you integrate this, you have to add 1, which will become minus half will become plus half. So you have to divide by 1 over 2. Then if you integrate minus 2zru, then you will get minus 2zr. Then here you will r will, sorry, 2 will get cancelled. This will become the bracket term will become power plus half. So that can be written as square root of z squared plus r squared minus 2zru, and this 1 over rz term will come here. Now we have to apply the limit. Before that, you can cancel this square and this r. So this will become sigma r divided by 2 epsilon z. That's what I have written here. Then you apply the limit minus 1 to plus 1. For u, if you apply a plus 1, this will be z squared plus r squared minus 2zr, which is equal to z minus r whole square. So I remember that there is a square root. Similarly, if u is minus 1, this minus of minus will become plus, that is z squared plus r squared plus 2zr. That means this is z plus r whole square. Of course, with the square root, you will get like this. Remember that this minus, because we are integrating this, you are getting minus. That minus, if you bring inside this bracket, then this will become, this will get interchanged. That is square root of z plus r whole square minus square root of z minus r whole square. Now we got this expression. You have to be careful when you are removing the square root. Here let us take, if this square root must be a positive quantity. There is no negative square root. So when z is greater than r, z is greater than r, then this is the positive quantity. You will get uh, this as z minus r, because z is a bigger number. If you take the square root of this, square will get cancelled. Z minus r, this is z plus r. There is no problem with the first term. So now what will happen when z is greater than r? This is r, radius of the sphere. Z is greater than r means this is outside. So at outside, if you add these two, subtract this term, that is, there is a negative sign minus. So here in this expression, z will get cancelled, and you have r minus r is plus r. So r plus r 2r, you will get this 2 will cancel with this 2. So you will get sigma r squared. This will become r squared divided by epsilon naught z, divided by epsilon naught z. Let us say r is greater. That means the point z is inside the sphere. So this is outside, no doubt about it. This is outside. Then if it is inside, z is less than r, that is the radius of the sphere. So you can take r minus z, you can interchange r minus z. In this case, it is r and r will get cancelled, and z minus of minus z is plus z 2z. So 2 will get cancelled, and z also will get cancelled. You will get sigma r divided by epsilon naught. So now this is inside. This is inside. So what will happen in terms of R, right, and the total charge of the cell is Q is equal to 4 pi epsilon, 4 pi R squared sigma. Then what is sigma? From here, sigma is equal to Q divided by 4 pi R squared, capital R squared, remember that. So in the first case, if you substitute sigma by q pi 4 pi r squared, that is sigma we are using q divided by 4 pi r squared, capital R squared. Here you have r squared epsilon naught z, r squared epsilon naught z. We are replacing z by r. In terms of r, we are going to calculate. So this will be. Now this r squared and r squared will get cancelled. You will get pi, of course. This will become 1 over 4 pi epsilon naught. This is epsilon naught, 1 over 4 pi epsilon naught. Here it is 1, we are replacing. So 1 over 4 pi epsilon naught you bring here, q by r. If r is greater than capital R, what will happen the next case? That is, it is inside. Sorry, this is outside. This is outside. We have used. This is outside. What will happen inside? That is, R is less than the capital R. Then you have to use, that is inside. Sigma you know is equal to Q divided by 4 pi R squared, and here you have R epsilon naught. Here what will happen? This R squared, this R squared will get cancelled with this R. This will become 1 pi epsilon naught. So you can rewrite this as 1 over 4 pi epsilon naught Q, this Q divided by this R, Q by R. If R is less than small r, that is inside inside the sphere, potential is 1 over 4 pi epsilon naught Q by R. Outside the sphere, this is 1 over 4 pi epsilon naught Q by small r. Thank you very much for watching my video and supporting me continuously. Thank you very much.